Hi, here we are discussing about the Part A instrumentation experiment, colorimetric estimation of copper. Here the theory of the experiment is the variation of color of the system with change in concentration of some compounds form the basis of colorimetric analysis. And what is colorimetry means? It is a chemical analysis through measurements of the absorption of light radiation in the visible region of the spectrum with respect to the known concentration of the substance is called as a colorimetry. Okay, here we are measuring the amount of the light absorbed by the colored substance at the region of 380 to 780 nanometers with respect to the known concentration of the substance. And you know the colorimetric experiment is applicable for colored solutions. Okay, if they are not colored, no, we will be adding suitable reagents to make them colored. Okay, and the colorimetry is depending on a Beer-Lambert's law. What is the Beer's law states? The intensity of the transmitted light decreases as the concentration of the absorbing medium increases. What does the Lambert's law says? The intensity of the transmitted light decreases as the thickness of the absorbing medium increases. I told you in even in class, I think you remember. Here, no, very simple way of understanding this law is you assume a colored glass and a thick glass. Okay, colored glass and thick glass. Light is passing through. Light is passing through the colored glass and thick glass and plain glass. What will happen? In the case of the plain glass, almost of the light is coming out. Almost of the light is emitted. It's not absorbing any amount of light. But in the case of a colored glass and thick glass, all the light is not coming out. Why? Because the colored substance is absorbing some amount of light. Even in the case of a thick glass, it is absorbing some amount of light. Okay, so see here, the intensity of the transmitted light decreases. Yes, no, the intensity of the light which is coming out is decreasing. Why? Because the color substance is absorbing some amount of light. Okay, you compare like that so that you can remember easily these laws. Okay, and Lambert's law says the intensity of the transmitted light decreases as the thickness of the absorbing medium increases. Okay, in between light, you are keeping a thick glass medium, it is absorbing some amount of light, so the light coming out is decreased. The intensity of the light coming out is decreased. Now combine both the laws. What does the Beer-Lambert's law says? It says that the intensity of the transmitted light decreases as the concentration and thickness of the absorbing medium increases. Okay, it is said in other way, A proportional to epsilon Ct. Epsilon is the molar extension coefficient. It is constant for a given medium at given wavelength. Okay, what is C? C is the concentration, T is the path length. Okay, that is the thickness of the medium. Here in our experiment, we are keeping the path length constant by measuring the values in the same cuvette. So when we keep the T as constant, A is directly proportional to concentration. Absorbance is directly proportional to the concentration. More is the color of the substance, more is the amount of light absorbed. Less is the color of the substance, less is the amount of the light absorbed. And the advantages of the colorimetry is it is used to determine metals like copper, iron, nickel, etc. Okay, and compared to the other metals like titrimetry and gravimetric analysis, you will be getting a very accurate results. And this is about the instrumentation. Inside the what we use the colorimetric, no, colorimeter we use, no, photoelectric colorimeter. Inside it will be like this. Monochromatic light will be there and slit will be there. Lens will be there. Filter will be there to choose the light of the required wavelength. And this is the cuvette we are keeping the solution. Okay, and finally it will be showing the amount of the light of the amount of the light absorbed as a numeric values. That is the output. Fine. Coming to the experimental part. See here, the principle here is, I told you this experiment is applicable to colored solutions. If they are not colored, nothing to worry. We can add suitable reagents to make them colored. For example, the copper sulfate is light blue in color. Okay, so what do we do here? We are adding ammonia. When we add ammonia to copper sulfate, cuproammonium sulfate complex is formed. And the cuproammonium sulfate complex which absorbs a maximum amount of light at 620 nm. Here the question asked will be, at what wavelength we measure the OD, optical density or absorbance for copper sulfate? The answer is 620 nm. Why at 620 nm means? Because at 620 nm it absorbs maximum amount of light. Please to remember. And also the question asked here will be, what is the complex formed when you add ammonia to copper sulfate? The name of the complex is cuproammonium sulfate. Okay, which absorbs maximum amount of light at 620 nanometers. Coming to the experimental part. It's very simple. Okay, you know, you have to take 5 different volumetric flasks. Okay, it will be marked on it as 5, 10, 15, 20, 25, and one more blank, and one more will be there. That is the solution given by your examiners. That is called as a test solution. Fine. So first step, you have to take 5 flasks, that is marked as 5, 10, 15, 20 and 25. So what you have to do? You have to draw copper sulfate, equal amount, whatever it is marked now. For the first flask, you have to draw 5 ml, second flask 10 ml, third flask 15 ml, fourth flask 20 ml, and the last 25 ml of the copper sulfate. Clear, no? First step is draw copper sulfate to 5 different volumetric flasks, 5, 10, 15, 20 and 25 ml. Clear? Second step, you will be having 2 more flasks extra. Which are they? One is blank. Blank, name itself says nothing is there in that. Okay, blank. And the second one is a test or unknown copper sulfate. Unknown copper sulfate means the volume is unknown to you because the examiner will give you some amount of copper sulfate. That is called unknown copper sulfate or test flask. So you are having totally 7 flasks now. Which are they? 5, 10, 15, 20, 25. One blank and one test. Okay. So what is the second step? To all the 7 flasks, add equal amount of ammonium. Equal amount means to each flask you have to add 5 ml. To all the 7 flasks, add 5 ml of ammonia solution. Here one question will be asked. Why are you adding equal amount of ammonia to all the flasks? The answer is ammonia here is we are using as a coloring agent. Okay. In ammonia some impurities may be present. Okay. Even that impurities, they may absorb some amount of light. Right. So to nullify the error which is caused by the coloring impurities present in ammonia, we are adding equal amount of ammonia. To nullify the error caused by the coloring impurities present in the ammonia, we are adding equal amount of ammonia to all the flasks. Fine. After adding ammonia equally to all the flasks, make up the solutions accurately up to the mark. Mix it well and keep it in order. Order means 5, 10, 15, 20, 25 and blank and a test solution. Okay. Then what I have to do, how we can measure the optical density. You have to take the blank solution. You have to take it in the cuvette. Cuvette means a small test tube like apparatus. Okay. Small test tube like apparatus will be there. That is called cuvette. In that you have to take the test solution and you have to set the OD for 0 for blank. Okay. You have to take the blank solution and for that you are setting the OD for 0. And after setting the OD for 0, you just have to measure the other absorbance for the other solutions. That is, you are measuring for 5, 10, 15, 20, 25 and at last for a test solution. Clear, no? First you have to take the blank solution, set the OD for 0 and you are measuring the OD for all the other solutions. And after measuring the values, you have to plot the graph. Okay. See here, when you take the values, that is volume of the copper sulfate against the absorbance, you will be getting a straight line passing through the origin. You will be getting the graph like this. And from the unknown, you can calculate the amount of the copper sulfate which is present in the given solution per liter. Okay. And to see the demo and calculation part, you can click the given link. Thank you.